Welcome everyone to this presentation on smart ride sharing route optimization using dynamic programming and greedy algorithms. My name is Vinay Kumar Banda and today I will walk you through how hybrid algorithm techniques can improve modern ride sharing systems. Like so in this presentation agenda we're gonna discuss about the we will cover five key areas like introduction, literature review and proposed solution and the conclusion and the references used in this presentation. So in this slide we're gonna deep discuss about the challenges of the real-time ride sharing. Like modern ride sharing platforms like Uber, Delivery, Lyft are rely heavily on fast and dynamic accurate matching algorithms. As request increases dynamically, ensuring optimal driver rider matching and route planning becomes complex. So the goal of this project is to minimize the total travel distance and time using a combination of greedy and dynamic programming approaches. As we can see, the project objectives. The main objectives are optimize ride assignments and reduce total cost and time, and apply greedy algorithms for fast matching and use dynamic programming to create optimal multi-riding routing solutions. So we can see the expected outcome. Like by applying this hybrid approach, we can expect a noticeable reduction in time travel, lower operational cost, and significant decrease in driver idle hours. So when using this real-time experience, we can reduce the time, we can reduce the operation cost, and reduce the idle hours for drivers waiting for the riders. So in the next slide, we can discuss about the literature review and identified gap. So as previous research such as Metal focused on real-time ride sharing, but suffered from high con like they suffered from high computational cost. So the proposed reinforcement learning approaches but required huge data. Like other researchers used greedy hectorics but lacked optimally for multi-passenger rides. So this project fills the gaps by combining both speed and accuracy through a hybrid method. So the main theme, like the main objective of this project is to fill the gap by combining both speed and accuracy through a hybrid method. So in the next slide, we're going to discuss about the proposed hybrid greedy plus DP solution. So in this slide, we're going to discuss about the how the system starts generating a sample driver and rider locations and computing pathways distances, and then using greedy step to assign each driver to the nearest rider. After that, the dynamic programming optimizes multi-rider routes to minimize the total cost. So for example, if the rider is nearer to the driver, then the system optimizes to the nearest driver possible. So in the next slide, we're going to discuss about the block diagram. Like this diagram explains about clearly about the how the project runs. Like this slide shows high level structure of the system including data input, greedy matching, DP route optimization, and final evolution. So we can see that how it works, like input driver and rider coordinates, calculate distance and matrix, and greedy driver assignments, and dynamic programming route optimization, and then calculate total distance and improvement, and then visualize the routes, and then finalize the routes. So this is how the project works, and this is how the block diagram explains the mechanism of the project. So in this flowchart we're going to discuss about like how visually this flowchart explains how the algorithm process inputs data and performs matching and applies DP and outputs optimized route plans. So for example, we can see like let it generate random driver and rider positions, then it calculates the distance matrix, then if it's available riders, then it assigns to the nearest driver who is ready to take the rider, like they are called as greedy. Then all riders assigned, then available riders. So for each rider, they optimize the route and calculate the distance, and after optimization, compute the improvement and visualize the sorry and visualize the routes on 2D grid. So this is how the program, like the project works. The main theme of the object is the goal of the project is to minimize the total travel distance and time using the combination of greedy and dynamic programs. So the thing is to like it assigns the nearest rider to the driver. So conclusion, like the conclusion of this presentation is to conclude the hybrid approach provides a balanced and scalable solution for a real-time ride sharing and successfully combines speed with optimality and can be further improved by using real map APIs or live traffic integrations. Like the future work like if we integrate the live traffic data for more and accurate predictions for real-time adjustments and incorporate dynamic pricing adjustments based on demand and supply and traffic conditions, and then extend the model to handle multi-modal transportation, ride sharing plus public transport integration. So this is how like in the works that are required in the future for this project. So like so finally the main objectives are to to optimize the ride assignments, to reduce the total cost and time travel, and apply greedy algorithms for the fast matching, and use the dynamic programming to create the optimal multi-ride driving solutions and assigning the routes to the greedy riders. So this is about the project, how it how it successfully combines the speed with the optimality and can be further improved by using the real map APIs or live integrations. Thank you for watching.